Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to Introduction to Data Analysis in our Part 4. The link to the material is here at the bottom, and when you go to the Tidy Data section, you should be at this page. Now we're going to create a new R Markdown notebook, so we're going to go File, New File, R Notebook, get rid of all of the things boilerplate that is there, and I'm going to save this as an R Markdown notebook called tidy.rmd. Okay, so the tidyverse is founded on the philosophy of tidy data. So I've mentioned this a few times in previous workshops. Now we're going to actually find out really what I mean. Now the philosophy of tidy data says that if you format your data in a tidy manner, then this will simplify all later data manipulation and visualization. So the visualization and data analysis functions that come with the tidyverse are built on the assumption that the data they're processing is tidy. So it's your responsibility to load the data and then tidy it. So what is tidy data? Now this is detailed very clearly in the online book R for Data Science, but in summary, tidy data follows three interrelated rules. So the first rule is that each variable has its own column. The second rule is that each observation has its own row, and then the third row is each value must have its own cell. So let's now look at how this applies to that MetOffice dataset that we loaded in the last section. So here we can see that each row in this dataset corresponds to observations that are collected together through the year. So we must ask the question, is this data tidy? Let's go through the rules. So the first rule is each variable has its own column. Well, the month name is a variable. So month would be effectively the value, or the month would be the column header, but the actual value of the month is a variable. And as such, because we've used the month names as column headers, this means that no, we're not actually giving each month its own column. So it should be that we have month as a column header and then a column with all of the months. So let's have a look at the second rule. Each observation has its own row. Well, this isn't true because look, we have 12 observations through the year, spread through the year. So this means that we have 12 observations per row. So that definitely does not mean that each observation has its own row. And also we have here the end, an average of the rows, which is not an observation at all. So how about the third rule? The third rule says that each value must have its own cell. Well, again, we don't even pass this. So as I said, the value here for the month in 1659 is on this cell, but equally for 1660 it is at this cell as well. So the value January for every year is actually overloaded into one cell. It does not have its own cell. And as I said, each value must have its own cell, but actually this average here for the year doesn't really match any variable. It's a derived thing from the data. So again, it shouldn't really be in this table. So what this means is we're going to have to tidy this data up and try and format it so that we can make it obey these three rules. So the way we can do this, let's first actually load all of this data up. So in my notebook, I'm going to put in and read it just as we had as the answer for the last section. So let's say temperature is assigned from read table, and then remember we had the URL for the data, which was here. We had skip was equal to 6, if I remember correctly. We had NA was equal to C minus 99.99 and minus 99.9. And then just make sure I've got this right. Again, we'll have a look. Oh yes, and then we made sure that our years were set up so that we write in the years as an integer. So we're just going to make sure we have that in place as well. So col types is equal to cols date is equal to col integer. Okay, so that should then read the data up. Okay, so this has all of our data, and we've made sure that we have NA values for those last values here in 2020. Okay, so as I said, we need to tidy this data up. It's not in a tidy format at all, and so we can tidy the data first by using the select function. Now the select function makes it easier to select and also deselect one or more columns from a table. Now the general format is if I had some data here, so let's imagine I had general piece of data here. If I do select column name, that would mean it's going to select a single column from the data. If I had a C with multiple column names, that would select multiple column names from the data, like that. But also if I use a negative value is basically a deselect, so don't have that data. So if I wanted to remove the year column from my temperature, I could pass it through select, where I say don't give me the year. So let's see what we get. Here we are. We now have the table without that problematic year column at the end. Now the next thing we need to do is we need to change the table so that instead of us having multiple observations per row, so that we have this long table, instead we have a very tall table, a tall thin table, where every single row is just a single observation. Now this kind of rotating of a table is also called pivoting, and we can do that using the pivot longer function. So first I'm going to say temperature is assigned from here. Actually, no, I'm going to actually extend this and make it a little bit easier. So let's now, the next thing, let's do this on multiple lines as well. So the way pivot longer works is we use pivot longer as the function, this is what we're passing it through, and we need to say which columns are going to be pivoted into rows. So in this case we have the January, February, March, April, May, all of the month columns need to be pivoted into rows because 1959 January is an observation, 1659 February is an observation, 1659 March is an observation. So the first thing we pass in are all of the column names that will become rows. So in this case it's January, February, we have to type all of them in I'm afraid, March, April, May, do make sure you spell them right, June, July, missed a double quote there, August, September, October, November and December. So these are all of the columns that will be pivoted from being columns into rows. Now the next argument is we need to give a new column name for where the data is going to be placed. So effectively if the value 3.0 for 1659 January, well it's now going to be 1659 January 3.0. So what's the name of the column that contains the value January? Well, we want it to be called something like the month. So let's actually call this as the month, and you specify that with names too. And we're going to place it into the month. Now the actual values are going to have to go into a column as well, and so we need to give a name for the column that the values will go into. In this case, these are temperatures, so let's name that column temperature. Okay. And honestly, that's all we need to do. If I just run this, you will see, there we are. We've rotated this table now. So now we have every single row has one observation. And remember those column names, January, February, March, April, May, they have now been put into a month column, while the actual values have now been put into a temperature column. So we can see the entry for 1659 May is 11.0. Now this means that our data is now tidy. Each variable, which is a combination of date, month and temperature, now has its own column. So date has its own column, month has its own column, temperature has its own column, while each observation has its own row. So the observation for the variable 1659 April is 7.0. Now, one of the problems we have at the moment is this date is not really the right name for this particular column, because actually now it's the year. We can see quite clearly we have month on this column and date on this column. And so there's another function which is called rename, and what rename can do is rename the columns in our tibbles. So we're going to now pass this tibble now through the rename function. And the rename function is very simple. You just basically pass in first the name you want the column to have, and then the name that the column has already. So we're going to say the year column is going to be assigned from the date column. So if we do that, we can now see we have year, month, and temperature, which makes a little bit more sense. Now there's one final problem that we have with this data, and that's if you look at this month column, it's currently stored as a character, as a string. So it's seeing just the string, the piece of text Jan, Feb, Mar. It's not really understanding that this is a month or something which is categorical. Now this means if we had any typos, so maybe some of the names were wrong, then this wouldn't have worked so well. We would have missed out some of our columns. And equally, if we tried to sort on this column, we would find that months which are alphabetically lower, so for example, August would be sorted before September and before January. Now, what we really would like to do is turn these months into categorical data, and a categorical piece of data is called a factor in R. And to factor data, we need to use the factor function, which is included in base R. Now, the factor function takes two arguments, the data, which is going to be factored, and then what are called the levels. And the levels are the strings that correspond to the different categories. So what I'm going to do is I'm just going to, at this point here, just above this, now create the strings that will correspond to the categories that we want to categorize these months into, or the levels we want to categorize the months into. So we'll call it month levels, and this is really just this set of strings that we're going to place in here. So we're going to say there are 12 categories from 1 to 12. Category 1 is Jan, Category 2 is Feb, Category 3 is Mar, etc. Then we can pass our data through the factor function, so the mutate function. So if we wanted to factor, we would have to use factor, the data, and then the month levels. But what we're trying to do now is we're trying to actually change the data itself. And to do that, we need to use the mutate function. Now, mutate is a function where we can basically take a piece of a column and we can change it however we wish. So for example, I have my temperature data. So let's now put this into a variable. Let's call it historical temperature. Like that. Don't have this on the end. There we are. Now, historical temperature, if we look at it, is our set of data. Historical temperature, I forgot to run that one. There we are. Now, if we wanted to change the temperature column so that we say maybe added 5 Celsius to every single value, we could pass this through the mutate function, where what we do is we have a change that we want to set. So we want to say temperature is going to be equal to temperature plus 5. What this would do is it would say take every value in the temperature column and assign it to the result of the sum of the existing value plus 5. Which you can see here. Now what we want to do with our mutation is we want to factor our month into our month levels. And so we could do that by doing mutate month is equal to factoring month into month levels, like that. And I have got month levels, just make sure that was in. There we are. So you can now see month is then set as a factor. So these are now basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, where those numbers are represented by the strings, Jan, Feb, March, April, etc. Let's put this onto the end of this setting. So basically we're going to put mutate month equals factor month into month levels. And then we don't need to do this separately. And there we have it. If we now print this to the screen, what you will see is we've now read in the data and we've tidied it up and we've cleaned it so that it's now very easy to analyze. So okay, I've now walked you through all of the tidy data section on how you tidy data. And in this case, we don't have an exercise at the end. And so this means we've now completed this part. So I look forward to seeing you back in part 5 of the workshop.